Hi students, how are you all? Welcome everyone to my masterclass today on circuits. Good evening to each and every one of you. I can see all of your chats live on my mobile, and I can see more than 250 students now attending this live from various parts of the country. Amazing. And I can see the energy in the chats as well. I can see a lot of you are excited. A lot of you are saying that, JEE is approaching and we are very scared. So don't worry, my dear students. I am here today to lend you a little bit help on some of the stuff which I will be teaching you today is definitely going to help you achieve better results and better marks in your upcoming JEE. All right. Okay. So on that note, I can see many of you are joining this session for the first time and taking their first session on Vedantu. So for those of you, my name is Vamsi Krishna. I am the CEO and co-founder of this wonderful platform, Vedantu. And I am here today to take my webinar, an online class, a short class in fact, but it's going to be really action-packed because I'm going to teach you not any normal methods, not methods which you will find in any of your school books or even any reference material or even standard books out there. This is going to be extremely unique, and I promise you, you're going to have, not just fun, but going to learn a lot and something which you will not, get anywhere else. Okay. So today, being only the first session, I'm going to focus on the 12th topic of circuits. Okay. On maybe the techniques I will be teaching you is on the circuits, but it is applicable for any circuit. Okay. So today session I'll be taking some question of JEE itself. All right. And I'm going to teach you multiple methods to solve it. The methods, again, as I said, are geared towards maximizing, your performance and minimizing the time it requires to attempt it. All right. Okay, guys. So students, is every one of you excited to begin the class? I can see your chats on my mobile. So keep those, chats coming. Although I may not be able to reply to each and every one of those chats, right? But I'm seeing them. All right. There will be a lot of question answering also today. Okay. And I'll be asking few questions and I'll expecting responses on the chats, right? So, I am keeping my mobile with me and I'm looking at your chats. All right. So I can see a lot of good evenings, right? So my dear students, good evening. And I can see now this number exceeding almost 400. So 400 students attending this live from various parts of the country. So to each and every one of you, a very warm welcome. All right. Okay, guys. So as I said, time is short and there is much to cover today. So on that note, let us begin. Okay. So is every one of you excited to begin the class? Give me thumbs up. Say yo on the chat. All right. Now I can see a lot of views coming in. Okay. So guys, I'm going to now share my screen as well to you guys. So now I think you can see my screen. All right. And as you can see, this is me, Vamsi, and this is what we are going to learn today, right? As I told you, we are going to learn some new ways to solve any circuit. And why I wrote any circuit is because although the methods I'm going to teach you today is around the resistors, but the methods you can apply on capacitors, inductors, basically any circuit out there. Okay, right. So we are going to learn some amazing new methods to solve your JEE objectives faster. And my dear NEET aspirants, it is applicable for you as well. So although I have written JEE, okay, it's for JEE and NEET both. All right, or for that matter, any competitive exam out there. All right. And as I again told you, repeating myself, this will be the methods. Pay full attention because you will not find this in your standard books or anywhere else. Okay. All right. So on that note, let's begin. Quick intro of myself. I did my BTech from IIT Bombay, right? Long time back. And just like you, I was also many years before an aspirant who was preparing for JEE. And at this time, I was also pretty nervous. So it's completely okay to be nervous. I can see a lot of chats of you saying that I'm scared, I'm nervous. Completely okay to be that. All right. So don't worry. Today, what I'm teaching you is definitely going to help you a little bit in that. All right. Okay, I had the fortune, students, of not just being an aspirant and going out and clearing JEE. Okay, I did my BTech from Bombay, IIT Bombay, but after that, I also have been teacher, right? And in my teaching days, I taught offline and online both. Okay, and I've had the fortune of teaching many students, even top single digit AIRs. And some of the methods and techniques which I'll be discussing and sharing with you today are some of the techniques which these guys knew and that really helped them succeed. Okay, so on that note, we will begin, and I would want you all to pay full attention, okay, to these methods, right? Because these are very precious, and these methods I am taking it out from my own experience with a expectation that this will really help you get that extra edge over others. Okay, all right guys, let's begin now. So everyone, super excited? Yes? Wait, come on, I have to see those chats, okay? I want the session to be interactive, come on. Yeah, come on. Yeah, I can see now a lot of things, but still not enough to get my energy going. Say guys, if you don't, don't show your excitement, that I am not going to teach you any new methods, okay? All right. Now I can see lots and lots of messages flooding. It's just simply flooding, right? So guys, I mean, Likon, Nikanshu, Sahil, Aditya, Mohan, there are so many of you, right? And I'm sorry I can't take name of each and every one of you, but trust me, I'm seeing each one of that, right? And on that note, let us begin the session, guys. Okay, many of you are asking, sir, I am in standard 10th 11th, is this helpful? This topic is obviously of 12th standard circuits, but 10th standard also has circuits. Some of the method will obviously be a little high level for 10th class students, okay, but it's always better to know more, right? And it's not going to cost a lot of time. It's just going to be a 40-45 minute short session. All right, okay guys, now before I actually go ahead, now this might come as surprise for you, because a lot of students think that there are just 2 or 3 methods of circuit solving. So एक तो series हो गया, parallel हो गया, some of them like say Wheatstone bridge, and that's probably it, right? But to your surprise, there are lots and lots of methods, okay? And in my years and years of experience, I have researched and took out some of the best methods, right, which is going to really be helpful. So in today's class, I obviously won't have time to cover each and every one of them, right? But I'll show you the power of some of these methods. So I'll come back to this slide a little later. But before that, let me show you a question which actually came in JEE. And it was not a very easy question, okay? It came in JEE. And let me tell you once I show you this question. So this was a question. I don't remember clearly which year this was. So it was something like this. The values might also not be exactly the same. So I just do this from my memory. So this was probably the kind of question which it was, okay? And the question was that you need to find the current in this circuit. So let me just draw it out there. You need to find the current I to this circuit and to others as well, but primarily it was this current to this one, right? Now, the moment we see this question, the first thing which comes to our mind is series and parallel. कि क्या ये question हम series and parallel से कर सकते हैं? Can we do this question by series and parallel? So let me just quickly mark this, resistors. So let me call this resistor 1, resistor 2, this is resistor 3, and resistor 4. Okay, these are 4 resistors, my dear students. Now ये बताओ मुझको, let me see how many of you can actually tell me that what resistors in this question are in series and are in parallel. Can you tell me? 1, 2, 3 and 4. The question, there are resistors, right? Can you tell me which of these are series or which of these are parallel? Okay, now I am looking at your chats. 3 is in series of what? No, 3 is not in series. 1 is in parallel to what? Which of these are in series and parallel is what I am interested in understanding. So I am looking at your chats. Okay, great. I think Naveen is saying no thing is in series or parallel. I think that's very accurate. And some of you others have also said the same, right? None of the resistors in this diagram which you see, my dear students, are either in series nor in parallel, right? Because 1 is obviously not in series with 3 because there is this branch here, and obviously 4 is something which is joined below, so it's obviously this is also not in series or parallel. Okay, so the answer here is none of them are in series and in parallel, none of them, right? क्यों? क्योंकि देखो सिंपल है, series और parallel के लिए they need to be connected between the same 2 points. So none of those two resistors are connected between same 2 points, right? And neither are they in series. तो हम इसको series and parallel से तो solve नहीं कर सकते. So what is the standard way of solving it? If this question comes in your board examination, the standard way of solving it is Kirchhoff's law. Kirchhoff's law करेंगे, ठीक है? तो एक बार draw करके मैं बताता हूँ. How do you normally solve it? So typically you take some current, let's say capital I will go from here. Then from here you will assume some I1, and from here you will assume it to be I minus I1. Okay, so I minus I1 will come from here, I minus I1, and I1 is going, I1 में से let's say नीचे कितना जाएगा, let's say I2 जाएगा. Okay, नीचे I2 will go. So from here I1 minus I2 will go. Okay, I1 minus I2 will come from here. I minus I1 is coming from here. Both of them will combine. कितना हो जाएगा? I minus I2, because I1 will cancel. I minus I2 will come from here. ऊपर से I2 आ रहा है, दोनों add होंगे and I will enter here. Now my dear students, look very carefully. In this question, the standard way, if it comes in your boards, this is how you will solve it. If this is a standard question, how many variables do you see? There are 3 variables. What are those? I एक variable है, I1 is another variable, and I2 is another third variable. So there are 3 variables. So how many equations do we need to write in order to solve this question? 3 exactly. Yes, we need to write 3 equations and then solve them simultaneously to find the value of I, I1 and I2. That's right. And how do we form those 3 equations? Kirchhoff's second law. Right? You can probably point it as A, B, C, D. इसको लिख सकते हैं A, इसको लिखते हैं B, C, D. Okay, let's call it E and let's also call it F. So Kirchhoff's second law you will apply and you will take any closed path. I hope all of you remember this. Currents हर जगह हो चुका है, right? In your schools or wherever coaching institutes. So I hope all of you remember the Kirchhoff's second law. Yes or no? Students, everyone, folks, guys, every one of you remember Kirchhoff's second law? Yes? है कि नहीं? Yeah, KVL, exactly. Yeah, I'm looking at your chats. Okay, great. So you will form 3 equations using Kirchhoff's second law. One can be A से B से D से वापस A आएंगे. So this loop will give you one equation. Then probably this B C D B. This loop will give you the second equation, and probably this A C F E A will give you third equation. Right? So 3 equations you will write, 3 variables you have, you will solve it and you will get some answer. So this is a very lengthy method, naturally. It will take you at least 10 minutes probably, if you are good with it, with practice, to be able to form all those 3 equations and get that right answer. And assumingly you don't do this silly mistake of yours, जो कि हम हमेशा करते हैं, which we every time do, you will probably get the right answer. Now guys, think of it for a second. If this question could have been in your JEE, wasting 10 minutes on it is absolutely, it's a worse strategy, right? If you actually put 10 minutes on it, right, you're actually going to lose a lot of time, right? And it is not an optimized strategy. So इससे अच्छा तो this question को you leave only, right? It's better to leave this question only, because by doing it with this method, right, is even worse, right? So it's better to leave it only. हाँ भाई, this question comes in your board examination, then you can do all this because you will get 5 marks or 10 marks for it, whatever. But अगर ये JEE में आता है, NEET में आता है, any competitive exam में आता है, then you should be in a position to solve these questions within 3 minutes, under 3 minutes, ideally 2 minutes, right? And that is exactly what we are going to learn today. That how are we going to solve these complicated questions in like this, okay? And are you ready to understand these methods of how do we solve these questions very fast? Yes or no? Are you excited to learn those methods, my dear guys? Right? I don't see any yes here. I think you guys are not interested. Yeah? Should I leave the class? Go? Okay, now I see a lot of yeses. Okay, all right. Any which ways, that was joke. I'm not going to leave you any which ways, right? And I can see this number now almost 700. Great, amazing. Okay, chalo guys. Those of you joined in late, hi, welcome. Right? You missed my introduction. Any which ways, rewind the video and see it yourself. But okay, now the most interesting part. Okay, I am going to teach a method if you know that method that I'm going to obviously teach you, you would not even require to lift your pen to solve this question. Now, how about that? I'll repeat myself. You would not even require to lift your pen to solve this question. Right? Excited to know this? Alright, let's go. Let's figure this out. तो पहले तो मैं इसको delete करता हूँ जो भी मैंने लिखा है. Right? Yep. So let me just take this out. Alright. And let me draw this fresh. Okay. Now the method I am going to cover here, guys, again as I said, is something which is not a standard method, and I will teach this with a big disclaimer, and the disclaimer is please don't use these methods in your board examination. I repeat myself, please don't use this method which I am going to teach you in your board examination, right? All right. Why not? Because this is not standard part of your CBSE or whatever, and if you do it in your board, you will get a big 0. Okay. So with that disclaimer, these methods are for your competitive exams. Okay. So the method I am going to teach you is the method of symmetry, right? Now I am not going to teach you ki symmetry aaya kahan se, because that would take a lot of time. Okay. That how is symmetry, why is it symmetrical, and all that stuff. I'm not going to cover that today, because this is just a webinar, okay, master class, and I'm just here to give you exposure to these methods. Okay, so let me just write it here. This method is symmetry. Okay, now listen very, very carefully, each and everyone. It's important. Listen very carefully. Now I'm going to draw a line here. This is that line. Okay, now can all of you see and sense that this line, this green line which I drew, sort of behaves as a symmetrical line dividing this circuit into two symmetrical parts? Yes or no? My dear students, tell me. I'm looking at your chats now. I want your responses, please. Right? ये जो green color की line I drew, do you see this being symmetrical? Meaning by left side of the circuit and right side of the circuit are exactly symmetrical. Yes, no? Yes, everyone say yes. Great, lot of yeses. Perfect. Now, if circuits are symmetrical, think of it like mirror images. Mirror images की तरह सोचते हैं इसको कि left वाला and right वाला parts are mirror images of each other, right? Now comes the most important concept of symmetry. Always remember. Now everyone, listen extremely carefully to what I say next. Whenever two or more than two circuits are symmetrical, then the currents passing through those parts or to those circuits are also similar. I repeat again, listen very carefully. Whenever two or more than two parts of a circuit are symmetrical, then what it means is current passing through those symmetrical elements will also be similar. समझ में आया सबको? Clear? Now let me show you what that means here in this diagram. Okay, so this green color is basically that line is a hypothetical line symmetrically dividing this circuit into two halves, mirror images. So the concept of symmetry says कि अगर यहाँ पे करंट I1 जा रहा है, then symmetrically यहां से भी करंट I1 जाएगा. Also, if current from here is I2, okay, then current from here, mirror image, would also be I2. Got it? समझ में आ रहा है? If current through this is I3, then current through this will be how much, guys? Tell me, कितना होगा? मिरर इमेज है, यहां I3 जा रहा है तो यहां नीचे की तरफ I3 जाएगा. Got it? Understood? Right? Why is this so simple? Because the left part and the right part, there is a left and right symmetry in this. There is a left and right symmetry in this. Understood? Are you able to get this? Are you able to understand this or not? Right? See, don't ask why. Okay, why is later. Okay, why, don't have enough time in this lecture today to help you understand कि ऐसा हो क्यों रहा है. Okay, probably some other time. Okay, any which ways, I'll be taking a course, a very detailed course, right, on all the methods which exist in circuit solving, and I'm going to take that course for all of you guys, and I'll tell you that. But in today's lecture, being one lecture, let's not focus on why, let's focus on करते कैसे. So इस तरीके से symmetrical है. This is how you look at symmetry, and this is how you will draw the lines. Now, my dear students, the answer is not even, I don't even have to write an equation. If there is an I3 current moving here, and if there is an I3 current moving from here, I3 and I3 will cancel each other out, and the net current through 15 ohm resistor is what? 0. As simple as that. That's it. Question over. That's it. Question over. Right? Isn't it amazing? Tell me this. Did you like this method or not? Amazing, right? Did you like this method or not? Guys? Amazing, right? Now come on, chalo. Those of you who really love this method, right, wherein such a complicated JEE question we solved without even lifting a pen, right? So come on. For those of you who really liked it, come on, chalo. I would really want you guys to like, the video on YouTube. Who are watching, like and subscribe. I think most of you have subscribed. If not, you should, because you will get timely notifications of all these, master classes which we do on the channel, right? Acha, by the way, today is a special day, okay? I would want to tell you this. Today, Vedantu's YouTube channel crossed 50,000 subscribers, okay? Okay, EP, yes, right? So thank you all, dear students, for supporting us, right? It has been a very short journey, right? We launched this YouTube channel just few, I think just, 1 or 1.5 months back, right? It's been, few weeks, and, 50,000 subscribers. We really loved it. We had a small celebration of sorts also in the office today. So thanks a lot for each and every one of you who have been, loyal to us and been attending sessions. For those of you who are attending this for the first time, you should definitely subscribe. And guys, come on. Those of you who like this, click the like button. Okay, chalo, wonderful. Now guys, no. Did you like this method? Did you like this method? Yes? Chalo. One more you would want to do? One more you want to do or not? In order to understand the application of this? एक और करें? नहीं करें? Yes? Okay, cool. Alright, so let me now draw one more question, right? Which again is not a very simple question. It actually came in I don't remember which year, right? Some JEE, right? And let me tell you further methods to solve it, right? There is not a single method. So let me actually show a question to you, right? And then we'll figure out better methods to solve it. So एक question देखते हैं which is again symmetrical, okay? So let me show that question to you, right? So there is a battery. Look at the screen, everyone. So there is this question I'm going to draw. Okay, standard question. This is not a very tough question. It's a standard question. And let me draw the values here. This is 10 volts, sorry. This is 10 ohms. This is 10 ohms. Okay. This is, let's say, 5 ohms. And this is a 10 volt battery. Okay. Question clear? Now again the answer question. Okay, this is not 6, huh? Sorry guys, huh? My writing is great, huh? 5 ohms. Okay, this is 5 ohms. Okay. This is the 5 ohm. Now this question, right? This question in front of you, do you see is it symmetrical or not? Do you see this being symmetrical? Yes or no? Tell me yes, no. Jaldi jaldi batao. Come on. Let's do it fast now. Is this symmetrical? Yes? Hey guys, come on, yaar. I would want you to responses. Come on. Yes? Okay. Chalo, cool. Yes, of course it's symmetrical. How is it symmetrical? Same funda. If this is the green line, left part of the circuit and right part of the circuit, both are equivalent, symmetrical, right? So then what happens? Then what happens is current flowing through this part, if it is I, current flowing through this will also be I, right? तो अगर यहां से I current आ रहा है, यहां से भी I current आएगा, and I will combine and become what, my dear students? 2I. Okay, and this again it will be I and it will be I. Okay, so now you will say, sir, how does it help? Okay, if you have noticed this very carefully, this really helps you a lot. It actually helps you eliminate one variable completely, right? How? See, now if I actually look at this circuit and if I look at these points, okay, let's call it ABCD, A, B, C, D, E, let's also call it F, right? Now, in order to solve this circuit, I just need one loop. So let me take this loop A to F to C to B to वापस से A, right? And I'll solve this question. तो देखो simple सा है, A से F जाते हैं, तो it is minus 10I. I'm writing Kirchhoff's second law. From from F to C, if I go, it is minus 10I because 5 ohm into 2I, 5 into 2I, right? Then from C to B, no change, there is no element. और यहाँ से obviously minus से plus जा रहे हैं, तो it is plus 10 volt is equal to 0. 10 is equal to 20I. I is equal to 0.5 amperes. Answer आ गया, right? Are you able to understand this? If you don't use symmetry, I'm not saying you will not be able to solve this question, but you would have to use two equations, two variables. Obviously, lamba jata, right? If I have solved it in 30 seconds, you would take 1 minute to solve it. Agree or not? Okay. So this is all application of symmetry. All right, understood? Getting it or not? Okay, some questions I'll take. Okay, I see she is saying, does it work for circuits which are symmetrical in shape or in resistors or batteries in symmetry? It can work for any symmetry. She is right. Symmetry doesn't really. So you know it's like this. Symmetry, हाँ. वो बैटरी है कि resistors है कि capacitors है कि what है, it doesn't matter. Symmetry. And all these methods you can apply on capacitors also. Okay. All right, everyone. Got this? Right? Okay. Pranjali is asking a question. Pranjali is saying, sir, what is the difference between this and Kirchhoff's law? Pranjali, if you don't apply symmetry, then you would require two equations of Kirchhoff's law to solve this. What I just told you is, by using just symmetry, you can solve it by using one equation of Kirchhoff's law, which is also huge time saving. And all these methods, guys, is essentially going to help you save time. And that is exactly, my perspective. Okay? All right, got this? Anyone? Everyone got this? Now, I am going to complicate this question a little bit. Okay, I'm going to complicate this a bit. All right, so let me complicate this a bit. Okay, so I'm going to rub this off. Okay, and as some of you have already asked me in this chat box that sir, अगर ये resistor symmetrical नहीं होते, तो what would we have done? Okay, so let me show that to you. Okay, so I am just rubbing this off. Okay, all right, guys. Now let's see this. All right. Now I'm going to edit this a bit. Let's say this is 20 volt. छोटा सा change किया. Instead of 10 volt, I made it 20 volt. Now tell me, my dear students, is this circuit symmetrical about that green line? Yes or no? Jalal, come on, tell me. Is this circuit symmetrical now about the green line? Yes, no? No, right? Ab batao, now how do we solve this? How do we solve this? Standard Kirchhoff's law is the only method we need to solve it. And what is that method? For that method, we'll assume some current I जा रहा है, इधर से I goes, यहाँ से I, sorry, इधर से I1 goes, so यहाँ I minus I1, okay, this I1 will come from here, come from here, come from here, here it's again I. So how many variables are there in this question now? 2 variables. How many equations you require? 2 equations. तो वापस से वो पूरे 2 loops लगा के solve करना होगा, right? So here, without using symmetry, I have to use 2 equations. And in this question, obviously I can't use symmetry because this circuit is not symmetrical. Yes? Okay? Now, instead of using again Kirchhoff's first law and second law, would you be interested in knowing a method for solving this question again, which is even shorter and better than Kirchhoff's first law and second law? Guys, would you love to know that method? Yes or no? अब देखो यार, if you are excited only, then only I'll teach you. Otherwise, not going to get those secret methods. Okay, just kidding. All right. No, don't worry. I'm not going anywhere. My dear students, right? I could see this enthu, I could see this amazing energy, right? And be prepared to learn another amazing method. In fact, you know what? I'm feeling happy today. So I'll teach you not 1, but 2 methods to solve this question. Okay? Apart from Kirchhoff's law. ठीक है? चलो देखते हैं. तो यार ध्यान से सुनना आप. ठीक है? One method is typically, it's common sense, okay? It's not a method. It's all invention. You can call it Vamsi Sir's method for all, care about. So, this is a nodal analysis. What I do is, I will assume any point to be 0 volt. ठीक है? तो इस point को मैं 0 volt मान लेता हूँ. I can do that, okay? I can do that. We can assume any point to be 0 volt. And I would assume this point to be V volts. ठीक है? अब अगर ये 0 volt है, so ये भी 0 volt है. And this is 20 volt more. So this point will be at what? 20 volts plus 20 volts. And if this is 0 volt, this is at 0 volt. So this point is at plus 10 volts. Do you agree? Everyone, you will understand this? अब देखो मैं क्या कर रहा हूं. I will take I1 current coming here. I will take I2 current coming here. And I will take I3 current going down. Okay? And I will say I1 plus I2 is equal to I3. Obvious है. Net current coming is net current going. And current is potential difference. V is equal to IR. V is equal to IR. So I is what? V by R. V is potential difference between this resistor. So I1 will be nothing but potential difference across 10 ohms, which is 10 minus V. This point is at 10 volts, this point is at V volt. 10 minus V upon R, which is 10 plus. I2 is what? I2 is 20 minus V. 20 minus V upon 10 is equal to I3. I3 is what? V minus 0, which is V only, upon 5. So, one equation, one variable, easily you solve for V, get the value of V, put karo, I1, I2, I3, सब कुछ आ जाएगा. This is one method. Okay? There is one more method. Don't worry. Aram se chill. I'm going to tell you. In fact, you know what? There are... Okay, now you jump with excitement. This is one method, right? Apart from Kirchhoff's law. There is not one more method. There are 2 more methods, right? And let me actually tell you 2 more methods to solve this question on top of this method. Okay? Excited? Everyone? ठीक है? तो चलो. इस method को, right? You call it whatever. I call it zero potential method, right? So this is one method. And I'm giving these examples for this question. You can apply it, at multiple places, guys. This is all examples I'm giving you, right? With practice, you can apply it at multiple places, right? But you should know the possibilities, and that is my agenda of today's session, to tell you the possibilities. Because most of the students, are like, Sir series, Sir parallel, Sir Kirchhoff's law. That's it. That's what they know. But I wanted to open your mind and tell you that एक नहीं, 10 methods होते हैं. In fact, I told you, right? There are 13 plus methods, right? So this is one method. Okay? So this I assumed it 0 volt. This is, I can assume it whatever V. This is 0. This is battery. तो ये 10 ऊपर 10 का potential difference है. So if ये 0 है तो ये 10 होगा. 0 है 20 होगा. I assumed it. Assumed currents of I1, I2, I3. I1 plus I2 is equal to I3. Substitute values, get the answer. Okay. Now this is the second method apart from Kirchhoff's law. Then let us look at the third method. Okay. All right. So let me rub this off. Okay. Now this third method involves, right, little bit advanced technique which is again not covered in your standard books. You guessed it right, right? And again you will not use this in your board examinations. Okay. So now that method is I call it call it whatever you want. This is basically used for multiple batteries and I call it superposition. Right, let me write it. Superposition. Right. तो यार ये मेथड ऐसा है, स्टार्टिंग में you will find it little tough, little not so straightforward, but actually believe me it is very easy. Right. So this method is very simple. What this method is, it says whenever you have circuit with two batteries or more than two, break it into circuit of one battery. So I'll tell you the method. I'll not solve it. I'll just tell you the method. तो इस सर्किट को हम दो सर्किट्स में ब्रेक कर सकते हैं. वन विद जस्ट द 10 वोल्ट बैटरी एंड रेस्ट ऑल 10 ओम, एंड दूसरी बैटरी को उड़ा दो. सो दिस इज 10 वोल्ट, दिस इज 10 ओम, दिस इज 5 ओम, 10 ओम एंड 20 वोल्ट को इफ यू हैव नोटिस्ड आई हैव रिमूव, उड़ा दिया. ठीक है, 20 ओम इज नॉट देयर. Right? Now you can solve this question easy. Now you can solve this question easy. Yes or no? Arey Baba, yes or no? Tell me, come on. I'm looking at your chats again. Yes? Yeah? Come on guys, tell me, is this question now easy? Yes, of course. Why? Because they are in series parallel na. Ye 10 ohms and 5 ohms are in parallel because these 2 points. So 10 and 5 in parallel will be 10 into 5 upon 10 plus 5, right? 50 on 15. In series with 10, you can solve it, right? Now, when you solve it, you can find the currents in this. So let's say there is a current I1, there is a current I2, and there is a current I3. Easily निकाल सकते हो? You can find it easily, right? These currents. Okay. Now, on top of this, you will now take the first battery out and keep the second battery. Okay, I am drawing it. This one. So now 10 ohm, 5 ohm, 10 ohm, and this 20 volt battery is remaining, right? And this also you can solve by series and parallel, and here also you can find the values of the currents. Let's say this is again I1 dash. Let's say this is I2 dash. Let's say this is I3 dash. Okay, I3 dash and I3 dash. Okay, and this would be I1 dash. ये जो दो blue color and red color I have, I drew, ये सबको समझ में आया. This method is called superposition. I'll repeat it again. सब समझ लो. Whenever you have a circuit with two or more than two batteries, right? The concept says you need not solve it complicated wise. You can simply break it up into individual circuits with only one battery. तो बस one battery रखो, second battery को उड़ा दो. Okay, you can do that. Very simple. Now when you do that, your question becomes a simple series and parallel question. Now you have to find the values of the current in each and every branch. That also is easy. Current distribution say. So the concept of superposition says कि जो फाइनल करंट होगा इधर, लेट मी राइट इट हियर, फाइनल करंट हियर विल बी I1 जो कि इधर है माइनस I3 डैश जो कि इधर है. सो लेट्स टेक एन एग्जांपल. लेट्स से दिस वैल्यू इज 5 amperes and let's say this value is 2 amperes. Let's say you find it. So what is the current here? 5 minus 2, 3 amperes आ जाएगा. And similarly everywhere, and you can check this out, right? Obviously time is short today. I'm not going to solve this. I'll leave this as a homework for you. You can try this out in any question you have encountered in your entire 10th, 11th, 12th. You can apply this, right? And you will see that the answer will always match. Got it? समझ में आया सबको? Okay, somebody is saying that screen is not visible. Okay, let me take the screen off. Just a second, sorry. Okay. I think now you should be able to see that, image. Yes, you should be able to see this now. So this is what I do, right? So my dear students, again I am repeating quickly. Whenever you are confronted with a circuit with two or more than two batteries, right? What you are essentially going to do is very simple. You will break that circuit into two individual parts. If there are two batteries, you will break it into two parts. If there are three batteries, you will break it into three parts. If there are four batteries, you will break it into four parts. Normally, my recommendation is use it when there are two batteries. If there are more than two batteries, it's better to avoid this method because lamba ho jata hai, right? So whenever there are two batteries, break it up into two circuits with one battery each. Solve it simply. Find the currents, or finally the net current जो आएगा, it will be algebraic sum of those individual currents. Getting this method? Yes. Now I can see some of you saying, Priyansh is saying, sir, too big. Arey Baba, too big, right? But imagine, this is a simple question I gave. This question, this method is applicable for complicated questions. For complicated questions, Priyansh, if you don't know this method, by solving it by Kirchhoff's law, it will take you ages, right? So I showed you this method for this question, and I agree this question ko normally bhi karoge, so you will be able to solve it. But if I complicate this even more, right, then there is no way you will be able to solve it by standard methods. Then this method is best method. Okay? Now guys, are you liking this method? Yes or no? Everyone? Yes? Cool? Alright. If you're liking it, then I want likes from you. Okay? If you're liking it, then I want likes. Hello, come on, go and like. I want more likes. I'm not able to check how many likes are there. Ready which ways? I'll check after the session. Alright, now, how about, one more method, to solve this. You want it or not? Yes? Okay. Alright, there's one more method. Yes, believe me. Right? Let me draw this again for you. So this was our circuit. 10 volts. And this was what? This was 10 ohms. 10 ohms. And then there is this. What was this? This was 5 ohms and 10 ohms. Okay. This is 5 ohms. And then there was 10 ohms. And then there's this battery of 20 volts. Okay. Now, this method, is something still you can use because it comes from your multiple battery theorem, right? Normally, I call it Millman's theorem. Okay, forget about the name. Name is not important, right? The concept is this, that whenever you have batteries like this, you can assume this combination to be a cell battery combination with a cell and an internal resistor, and this also to be a combination with a cell and an internal resistor. Okay, so the concept is whenever you have multiple cells, I'll draw it here. Let's say this is E1 and this is R1, and let's say there is another cell which is E2 and this is R2, okay, and so on and so forth. The concept of cell battery or Millman's technique says that you can actually combine all of this and convert it into one cell and one resistor, right, having the value E and R, in which E का formula is equal to, ध्यान से देखना, E1 by R1 plus E2 by R2 plus dot 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 जितने भी है upon 1 by R1 plus 1 by R2 plus dot 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 dot, and R is the parallel combination. 1 upon R is 1 upon R1 plus 1 upon R2 plus dot dot dot. This, my dear students, is the most simplest formula you can use to not just solve this question, because ये question ना फिर भी simple है. This question is still simple, right? If I have given you more batteries, let's say there were only 2 more batteries here, right? इसके इधर, then तो applying Kirchhoff's law, even the superposition method would take you 10 minutes, 15 minutes to solve it. But this method, I call it Millman's technique, right? This method solves, using this formula, this question gets solved like, in one line. Okay, and that's the battery formula, right? In some of your books, in some good books, it's also given, like you can use this, right? But the actual method is not battery formula. The actual method comes from your Millman's technique. All right. Yeah, that's the real concept, right? I'm not actually going to put values and solve this, right? It's actually going to be very easy, right? Ye 10 upon 10, 1 ho gaya, plus 20 upon 10 is 2. So 1 plus 2 is 3 upon 1 by 10 plus 1 by 10, right? I think you can solve this, right? I'm not really going to go into algebra and solve this, right? But this method is the what? Third method or fourth method? Fourth method, right? The first method I told you was Kirchhoff's law. Then we did that 0-volt potential method. Then I gave you superposition method. And then this is the Millman's method. Okay. Now I think खूब सारे methods okay. Are you guys liking it or not? Tell me. Someone is asking me, sir, which book are all these? I mean, there's no book here. Okay. And there are many more methods, right? I was telling you this, right? Where is that slide? Let me go to that slide, okay? Yes, this slide, right? And my dear students, this is more methods which are actually there, okay? There is a series and parallel, sabko pata hai. Kirchhoff's first and second law, which everyone knows. But there is some loop method. Wheatstone, which also many know, right? So I think this one, most of you know. Loop method is something, a little different. Superposition principle, I sort of gave you an idea, but believe me, superposition is my favorite method, and it can be used to solve very complicated questions. And I'll show you one of those questions, just after this slide. Then symmetry method, right? I again give you a glimpse of it. There is something called anti-symmetry also, which is a little complicated, that's method. Now there is a Thevenin's theorem, Norton's theorem, Millman's, I told you little bit. Thevenin is like amazing, right? It's not so easy, right? Students don't get it the first time, but by 2 or 3 questions practice, this method can solve any complicated question out there in matter of seconds, right? Then one of my again favorites, star delta transformation. I did not have time today to cover this. This is again like super awesome, right? Then also there are a lot of questions on infinite circuits, right? And there are methods to solve it. And last but not the least, the circuits in which multiple components are there, RC circuits, right? And I'm sure you would have been exposed to that. So there are a lot of techniques to solve RC circuits as well, right? So my dear students, today's session being limited, I think I already reached my allocated limit of 45 minutes I wanted for this. But there are a lot of methods. I wanted to show you that the world is not limited to just 2 or 3 methods. There are so many methods. Some of it I told you today. There are many methods, and I am going to launch a course which is going to cover in detail all of these methods, all of these 13 methods, and in fact, few more, right? And I'm going to launch this course very soon. I'm going to give this details now. But before that, let me also show you this complicated question. Now, this question, you can actually use star delta transformation to solve it, right? And I'm going to cover this and many such complicated questions, right? And I'm going to show that in the the course which is going to be launched very soon. I'm also going to give you the link of it, right? So those of you who really like this session, I want more likes for you. So sabse pehle go and click like, okay? And those of you who are interested, especially the 12th class students and also 11th standard, right? Especially the 12th guys and the topper guys who are going to appear for your JAN, JEE mains. These methods are going to be super helpful and help you solve the questions of resistors, capacitors also, inductors also in faster method, right? So if you actually go to this link, vdnt.in/any circuit, I'll just go here. right? So you can register here. So vdnt.in/NE circuit. Okay, so this is the page. You can actually go and find details. Not all the methods is written here because space was not there, but these and all the other methods, 13 methods I told you, is what I'm going to cover, right? And we launched this course as a 999 course, but for all the students who are watching this live webinar today, especially for you, okay, this is going to be 499 for the remaining whatever 2 hours, right? So it's going to be super beneficial. Some of you are writing on the chat that, sir, I have classes during this time. Don't worry, if you enroll for it, even if you miss 1 or 2, you will get recordings of the sessions, right? So it will be super valuable. So those of you who are interested in learning all the methods in very detail, right, enroll for this course. We'll also have a sort of a chat group wherein I will be there and we will be discussing many of these questions, and I will be giving you some assignments also as part of this course. So this course is going to be launched on 30th, so still a lot of time there, right? And yeah, you can find details on this. Okay, now my dear students, before I leave, right, again on one final note, tell me sincerely and frank feedback, did you like the methods you learned today? Yes or no? Come on, tell me. Yes, no, right? I would want to see your responses on the chat. Yeah? Okay, cool. Amazing. Right? Alright. So much love out there. Right? Lovely. It's always our dream at all the teachers here at Vedantu. We do these sessions, and it's our sincere attempt that we try to make it very condensed and make this 45-30 minutes 1 hour sessions very productive for you guys. And the whole objective behind this is you study, you have your books and all, but there are a lot of things, small things, which create a lot of difference. And as students, our students, if you know these methods and you get that edge over others, okay, who are probably your classmates and counterparts who don't know these methods, and if you can save even 5 minutes using this method, that 5 minutes you can use to solve 1 or 2 more questions, that will give you more marks, and that is going to give you an amazing delta in your rank, right? Believe me, I paid for these exams, and even 1 mark displaces hundreds and hundreds of ranks. That's how competitive these exams are. And I sincerely believe you will practice these methods, because otherwise it will be a wastage of my time and your time. I really want you to practice these methods, and I also would love to see many of you coming for the course, and I'll meet you all in that course. Okay, on that note, I'll take your leave. Thanks a lot for joining in for my session tonight. Have a great evening. Okay, take care. Bye bye. And most importantly, all the very best. Okay, especially for 12th standard and dropper guys who are going, JEE is coming. All the very best, right? Do great. I'm sure you will come out with flying colors. All right, guys, this is Vamsi signing off. Bye bye.